Can you all see my screen? All right, all right. Acha ji. So to begin with this thing, this is the question that is there before us, and the question it states show the by expressing them as fractions or whole numbers, whether the following numbers they are rational. We have to prove whether these numbers they are rational or not. People who attended the first lesson, Sir Arman and Miss Aisha, can any of you quickly tell me what rational numbers are? Arman sir, what are rational numbers? Arman, Miss Aisha, what are rational numbers? So for example, going by your definition, if I say 6 out of 100, is it a rational number or not? But it's not a whole number. If I convert it, what would it be? It would remain a fraction. 2 3s are 6 and 250. It would still remain a fraction. Any number which can be expressed as a fraction, and for that fraction I can find a definite answer. So if I write 3 by 50 on the calculator, 3 divided by 50, what do I get? 0.06. So it has a definite answer. There is an end to the numbers that I get for this answer, so it would be a rational number. Whereas opposed to if I am solving for an irrational number, so for example, do all of you have your calculators with you? Miss Anam, Sir Ilyas? All right. Quickly type on your calculators 22 divided by 7 and tell me what the answer is. 857. This number 22 by 7, this is a special number and we'll be using this a lot later on in the portions of geometry. This number is called pi. Okay, pi is an example of irrational number. What's an irrational number? As you can see on the calculator, there is no end to. So for example, if you are using a more advanced calculator, it would give you answer to even more decimal places. So there is no end to solving this number. So this is an irrational number. Similarly, if you were to find out under root of any number other than a square, so for example under root 3, quickly type on your calculators square root 3. What's the answer? Or if you were to find out the answer for square root 2 on your calculators, you can see that it goes on 1.414213562, and there is no end to the digits that I get after the decimals. So it means that this is an irrational number. Similarly, a root in a fraction form, so 1 over root 5 for example, on your calculators quickly write 1 over root 5. G. What's the answer that you're getting? Miss Anam, do you understand what we're talking about, or is it all going above your head? Okay, okay. 1 over root 5. Miss Noor, are you there with us? 0.447213595555, and it goes on. So these are all examples of irrational numbers. So if we have to prove whether a number is rational or not, what we have to do is we have to convert it into a form, a fraction form or decimal form, and we have to find out there is a definite answer to it. So 0.625, since there isn't anything going on after this, so that itself proves that this is a rational number. Okay, Miss Anam, do you get it? 0.625. Does the number end over there, or is there anything after it as well? It ends at 0.625, which means that there are no decimal places, no digits after 0.625. So it means this number, it has a definite end after the decimal form. in the decimal form, there is an end to the digits that I get. So this would be a rational number. Okay. Similarly, Sir Arman, can you quickly tell me what would be the answer of cube root of 27? Wrong, wrong, wrong. Sir Elias, what would be the answer of cube root of 27? Okay, this is something that we discussed in the last class as well. Cube root, whenever there is a power written over here in the root, this can be written as 27 to the power 1 over 3. First thing. This step do you get, Miss Anam and Sir Elias? So it would mean, first of all, 27 to the power 1 of 3, then it would be equal to 3. And the next step would be that I can write 3 to the power 3 instead of 27. And the power on top of it, 1 over 3, it stays as it is. Miss Anam, do you get this step? So this 27, I just expressed it as 3 to the power 3 because 3 3s are 9, 9 3s are 27. Okay, so instead of 27, I wrote 3 to the power 3, and then the power on top of that 1 by 3 that stays as it is. Right? Arman sir, Anam, you still don't get it? You don't understand. So first step, did you understand this? That we can write cube root of 27 as 27 to the power 1 over 3. Then instead of 27, this power 1 over 3 I'm writing as it is. Instead of 27, I wrote 3 to the power 3. Can I do that? Your mic is mute, Miss Anam. So instead of 27, I write 3 3s are 9 3s are 27. So this can be written as 3 to the power 3, right? So that's what I did over there. And 3 to the power 3, and on top of that power 1 over 3. Now the rule is, if I have got a power on top of a power, so the powers, they would multiply. And if I multiply 3 with 1 over 3, the answer would be 1. And 3 to the power 1 will be equal to 3. Okay. One more thing I mentioned in the last class, there is a lot of things that I have mentioned in the last class. So what I'll do for now is I'll just quickly go through the solution of these questions, since they were discussed in the last class, the concepts behind them. Uh, Please, all of you who didn't attend the last two classes, send me a message in private. I'll send you the links to those classes and you can watch those lessons and get up to speed. Okay. After the class, I'm there in the group. Just send me a message in the private chat and I'll share the link of the recordings of last two classes with you people. All right. Okay, Ji. Moving on. This 0.44, again, I can see that there is an end to the decimal, the digits after the decimal. So I know this would be a rational number. All right. The next question that we have, find the value of 9 squared. What does it mean, 9 squared? 9 squared simply means 9 times 9. So the value of 9 squared would be, Mr. Elias? Excuse me. What does 9 squared mean? Yes, 9 times 9. So what would be the answer of 9 squared? 81. That's it. Acha ji. Then we have 15 squared. What would be the answer of 15 squared? Miss Anam. Mr. Elias, please don't tell the answer. Miss Anam, what's the answer of 15 squared? 225. Okay. The next one that we have is 0.2 squared. Miss Noor, are you there? Miss Noor? What's the answer to 0.2 squared, please? You don't have a calculator. For math classes, all of you always carry the calculator with you. Even without the calculator. Sir Arman, can you tell me how can I solve it without the calculator? 0.2 squared. So there are two ways to solve it. One is you simply do the old way you learned the multiplication 0.2 times 0.2. The other, perhaps a quicker way, would be that 0.2 can also be written as 2 over 10. This is something that we'd again learn more about in the fractions portion that we would do next. So 2 by 10, this is 0.2, and 2 by 10 squared would mean 2 by 10 into 2 by 10. So this gives me 4 by 100, and 4 by 100 I can write as 0.04. So 0.2 squared would be 0.04. All right. Miss Anam, you look confused. Miss Anam, quickly either keep your mics unmuted, because since you are in the class, so there shouldn't be any noises around you as well. Or if I ask you a question, please quickly unmute your mic and respond me. Either keep your mics unmuted, or quickly unmute them when I call you out. G, do you understand this? That the last question that we did, 0.2 squared. All right. So then you can tell me how to do 0.7 squared. What would be the answer? So I write 7 over 10 instead of 0.7, and then to square it, I multiply it with another 7 over 10. That would give me 49 by 100, which will be equal to 0.49. All right. Okay, Ji. Similarly, on your calculators, we also extensively discussed how we use the calculator in these situations in the last class. Again, once you go through the recordings, you would get to that. The 3.5 squared. How do you do it in your calculator? You write 3.5, and then there is this button x squared. You simply press that, is equal to, boom, you get the answer for 3.5 squared. Sir Arman, what's 3.5 squared? Answer. Mr. Elias, what's 4.1 squared? Quickly, the answer. 16.81. Okay, Miss Anam, what's 0.15 squared? Miss Anam, 0.15 squared. 0.0225. Okay, Jish. Okay. Moving on to the next part, we have to know how to do these without the calculators. So the way to solve it is, first of all, I know I can write 225 to the power 1 over 2, right? That's the basic step, first step. So once I write it as 225 to the power 1 over 2, then in order to solve it, I know that I have to reduce the inner value into something so that it becomes square. Inner value should be a square of something so that it cancels the power 1 over 2. What is 225 a square of? So if you don't know that, the other way to do it is break it down into factors. What would be the factors of 225? 5 into 5 into 5 into 5. These would be the factors of 225, and then I can write it as power 1 over 2, right? And then this 4 fives that I have written, I can write as 5 to the power 4 times 1 over 2, and power 4 cancels, multiplies with this 1 over 2, it becomes 5 squared. So 25, 5 squared, or 25 is the answer. Gee, everybody understood? Anybody who did not understand this? Okay, so root 225 root 225, I have to break down this 225 into its factors. How do we do factors? Again, in a detailed way, you would learn from the recording of the previous lesson. So here we have 225. We break it down into factors. 5 4s are 20. 5 5s are 25. And then 5 9s are 25. Just a second. Did I make a mistake over there? Did I make a mistake over there? I did. This solution was wrong. There was a mistake. Acha ji, 5 45, then 9. So I write 3 3s are 9 and 3 1s are 3. Ji, any confusion in this factorization? Did all of you understand this factorization? Miss Noor? Miss Noor? All right. Did you understand this factorization that I just did? All right. So now I can write down these factors. Instead of 225, I can write 5 into 5 into 3 into 3, right? To the power 1 over 2. All right. Then I can write 5 squared into 3 squared to the power 1 over 2. So when two values are multiplying inside the bracket and there is some power outside it, this power it would individually apply to both the values inside the bracket. So it would become 5 squared times 5 to the power 2 into 1 over 2. So let me write that 5 to the power 2 into 1 over 2 multiply by 3 to the power 2 into 1 over 2. Okay. And then these powers they'd cancel out and I'd be left with 5 to the power 1 into 3 to the power 1 and the answer would be 15. Miss Anam, did you understand this thing? All right, all right. Acha, one more thing I mentioned in the last class and I'll quickly mention it right now. 5 to the power 0. What would be the answer, Miss Noor? What's the answer of 5 to the power 0? Mr. Elias, what would be the answer to 5 to the power 0? 1. Excellent. Anything at all in this world raised to the power 0, the answer would be 1. 1000 raised to the power 0, answer would be 1. Arman raised to the power 0, answer would be 1. Saad raised to the power 0, any number, any x raised to the power 0, x, y, z whole raised to the power 0, answer would be 1. Okay. And anything raised to the power 1 is that number itself. So 5 raised to the power 1 would be 5. 3 raised to the power 1, 5.6 raised to the power 1 would be 5.6 and so on. Okay, so we have to know the difference in between something having a power of 0 and something having a power of 1. Any confusion to anyone this far? None. Okay, moving ahead. So we did for 225 the same way we have to do for 0.01. So the way we do that is root 0.01. Root 0.01. So the easier way to do it is to convert it into a fraction. 0.01 would be 1 over 100. And then I can say root 1 over 10 squared. And then I can say root 1 over root 10 squared. So square and root they cancel. And also for 1, root 1, the answer would be 1. So 1 over 10 or 0.1 would be the answer. All right. Root and square later on. Okay, so here right now we are understanding the logic behind it as well, but later on we'd be using this thing very frequently, or maybe you have done it in the past as well. So for example, if you have got a root and within the root there is some square number, so your teachers tell you that root and square they cancel each other and the answer would be x. The reason is why do they cancel each other? And that reason I just told you that x squared, and if there is root on top of it, it would mean that it has power 1 over 2. And if there is power on top of power, the powers, they would cancel each other, and the answer would be x to the power 1 or x. All right. Okay, ji. Quickly back to 0.01, then 0.81. Again, I can convert 0.81 into fractions. It would become 81 by 100. Sorry, 81 by 100. 81 by 100 would mean 9 squared by 10 squared. So the answer would be 9 by 10 or 0.9. Okay. Moving on for 9 by 25. I know it is 3 squared by 5 squared, and then there is root on top of that, so squares, they cancel root of each other, so it would become 3 by 5. Miss Aisha, hopefully the answers that you got, they are matching with the explanation that I'm saying right now. Okay. So same for root 5 into 4 by 9. So root whole 5 whole 4 by 9. So we can convert it into an improper fraction and then solve the roots. Same for 2 whole 23 by 49. Acha ji, for doing the next question, 4 cubed. We know that there is power on top of 4, so 4 times 4 times 4, that would be the answer to 4 cubed. 0.1 cubed would be 0.1 times 0.1 times 0.1, or for the sake of simplicity you can do 1 by 10 into 1 by 10 into 1 by 10. Then we have got 2 by 3 cubed, so that would mean 2 2s are 4 2s are 8, 8 by 27. All right. Finding the cube root of the following numbers. So here we have to find the cube root. 27 cube root. Hopefully the answers that you got, the factors of 27, they would be 3 times 3 times 3. So 3 to the power 3. On top of that, for cube root, it will become power 1 over 3. So the answer would be 3. For 1 million, it would be 100 into 100 into 100. And the answer would be 100. So for this 1 million under root, the solution would be, let me write over here, cube root of 1 million, right? And then this 1 million I can write as 10 to the power 6, and cube root, it would convert into 1 over 3 power. So 6 and 3, they'd multiply. 6 and 1 over 3, they'd multiply. The answer would be 10 to the power 2, which is equal to 100. So for those of you who missed the last class, I can understand that for now the same, it might seem to be a little bit fast, but since I've covered this thing in detail and I'm saying it one more time, that I'll give you the recordings and you can refer to those recordings, and then the recording of this lecture as well. You can rewatch them both, and then hopefully these things, they'd make more sense to you. And for the last one that we had, a cube root of 64 by 125. So 64 we'll have to convert into factors. So if we do factors of 64, it will become 4 times 4 times 4. 4 4s are 16, 16 4s are 64. And if you do factors of 125, they would become 5 times 5 times 5. So root 64 by 125, it would convert into cube root of 4 cubed by 5, 5 cubed. So cubes, they would cancel the cube root, and the answer would be 4 by 5. Miss Aisha, you got the same answer? Now you understand how to do it?